All right. We're going to take a look at some of the work we did today. Essentially, we're going to try to determine when we are given a position function here, s of t, for positive time value, t greater than or equal to 0. What we're going to try to determine, first of all, is the velocity function, v of t, or s prime of t, that we see up here. And we're going to try to determine where that particular particle stops when it moves to the right, which is really the positive direction if it's horizontal, up if it's vertical. And when it moves to the left, which is thought of as the negative direction or down. So the negative direction is either left or down. It's left if it's horizontal, it is down if it's vertical. So we discussed this earlier today. So we need the derivative because the velocity function is the derivative. Well, let's give you every detail. Is the derivative of the position function with respect to time. So, okay, s is going to be t cubed minus 6t squared plus 9t. So let's use our properties of derivatives. And let's see what we get. We're going to get here 3t squared. We're going to get here 2t. And this is 1. So we have 3t squared minus 6 times 2t is 12t. Plus 9 times 1, which will be 9. So don't forget here, excuse me, to do your arithmetic here. And this is my velocity function now. Okay, this is AKA S prime t. So it's the derivative of the position function, which is also known as the velocity function. So here's my position function now. The velocity function I just found. And if we want to find where the particle stops, what we mentioned today is that the particle stops when your velocity function equals 0. That's when the particle stops. The particle moves to the right when your velocity function is positive. It moves to the left when that velocity is negative. So hence, we really need to do sign analysis on the first derivative, on the velocity function. And so we can remember all of this. This is just your position function with time t. So we're going to do sign analysis on the velocity function. Okay. So this is really the name of the game for this section. It's going to give us all that information we care about. Okay. Now, the first step in sign analysis, if you guys recall, is to let that velocity function equal 0. That's really also finding where your particle stops. So let Vt equal to 0. And we end up with 3t squared minus 12t plus 9 is 0. Now notice the quadratic on the left is factorable. The greatest common factor is 3. Now this implies that my t squared minus 4t plus 3 will be equal to 0. Now I can divide both sides here by 3 and we get cancellation. Sometimes students need to see this detail. So there's a few ways we can look at this. So 3's cancel, and then 0 over 3 will be 0. Okay, this is a quadratic here. We have to solve this quadratic by factoring. Hopefully it's factorable. And we'll use the crisscross method. So I need two numbers whose product is a positive 3 and whose sum is negative 1. So negative 1 times negative 3 is in fact positive 3, and negative 1 plus negative 3 is negative 4. So these are the numbers. So that what that means here is t minus 1 times t minus 3 equals 0. Okay, so remember, by the crisscross method, we use the numbers found in the method. Now, by the zero product rule, any two numbers multiplied together is 0. That means t minus 1 is 0. T minus 3 is 0. Solve for t by adding 1 and adding 3 to both sides. T is 1 second, and t will be what? 3 seconds. Okay. So this is the location where the particle stops for these times. I should say this is the time for which the particle stops. Okay. So we found the time where the particle stops. Now in sign analysis, remember how that even works. You got 1, you have 3. You put the zeros here. This is the velocity function, or s prime t. And we have 3 regions to check. But never forget that the time is strictly positive. We don't have anything, there's no such thing as negative time. So when they define your position function, they always say let t be greater than or equal to 0. T is positive, time's positive. All right. Okay, so what does that mean? I can use 0 for a test point. 0 is available, but nothing to the left of 0 is available. I could use 2 as a test point, and I could use maybe 5 as a test point. We're going to need to test every region. We're going to test it for the sign. So we need that velocity function. Okay, so I'm going to take down this velocity function maybe here. And we're going to test every region. Okay, when we test 0, we're finding v of 0. Notice what v of 0 becomes. It looks like it's positive 9, and I guess if that's not centimeters, that'll be centimeters per second. Not sure what those units are. Time was in seconds. Well, that number's positive, so that means region 1 is positive. Okay. Now we're going to check the sign. This is sign analysis when t is 2 now. So we're going to plug in 2 here, and we're going to have a different arithmetic, meaning 3 times 2 squared now minus 12 times 2 plus 9. 3 times 4 minus 24 plus 9. 12 minus 24 plus 9. Negative 12 plus 9. V of 2 is negative 3. So that's probably like negative 3 centimeters per second. So we're going to need another page. The point is, it's negative. So the sign of region 2 is in fact negative here. The sign now of region 3, we're going to test when the value of t now is 5. This is sign analysis. So we're going to get some different arithmetic here. And we just care about the sign, but we are getting the exact values. So plug in 5. We get 3 times 5 squared minus 12 times 5 plus 9 will be 3 times 25 minus 12 times 5 is 60. So we get 75 minus 60 plus 9, or 15 plus 9. So that's 24 centimeters per second. So when the time is 5 seconds, velocity is 24 centimeters per second. The point is it's positive in region 3. So, ladies and gentlemen, we're performing sign analysis on the first derivative, and that's going to give us what we need here. Okay, so yes, I got some values there. But okay, now you might say, what does all of this mean? Okay, this is going to be our conclusion step. You remember the question? For what time t does a particle stop? That happens when the velocity equals 0. When is it moving to the right, which is the positive direction? Well, when the velocity is positive. And when is it moving to the left? When the velocity is negative. So we are finding via sign analysis every one of these equations and inequalities here. That's the beauty of sign analysis. Now, here's what we want to know. Let's see, going to the right is in the positive direction, so that's green. So go back over here, and in green, this is where the velocity is positive for these values of t. In orange is where your velocity is negative. Remember, this is testing the sign of the first derivative, which is velocity. And where it equals 0, where t is 1 and t is 3, that's when the velocity is 0. That means that's where it stops. So here's the deal. It stops, when time is 1 and time is 3 seconds. So your velocity, the particle stops at 1 second and 3 seconds. The particle moves to the right for t. Now, I think we checked 0, so for t less than or equal to 0, strictly less than 1. And then we say, or t being greater than 3, not equal to 3, but strictly larger than 3, because this is where this interval is talking about here. Then you have this interval over here. If you said, I want interval notation, okay. From 0 to 1, union 3 to infinity. There's your interval notation. Okay, the particle moves to the left for 1 less than t less than 3. So all I'm looking at is that real number line. You guys can see these answers here, maybe, if I color coordinate it. And in terms of interval notation, this is the values of t between 1 and 3, not including 1 and 3. So, ladies and gentlemen, that's kind of what they're looking for. I just want to let you know. And you're really performing sign analysis on the first derivative. And that's pretty much it for every one of these questions. Sign analysis on the first derivative. Okay. and then interpret your sign analysis because that's the velocity. All right. Now, we're going to try another one here. Now, this is the position function of this curve. If I want the velocity of this function, I need to differentiate this function. I need ds dt. Which is d dt. S is t over 1 plus t squared. Now, we're going to use quotient rule. Let's hope we don't even run out of space. 1 plus t squared. Differentiate t minus t. Differentiate 1 plus t squared. Okay, the derivative of t now is 1, and the derivative of 1 plus t squared will be t2, 2t. So we have 1 plus t squared times 1 minus t times 2t. And then this will be over 1 plus t squared squared. And let's do some arithmetic here, or algebra. So my velocity function becomes 1 minus t squared over 1 plus t squared squared. This is the velocity function. We need this because we're going to perform sign analysis with this function. I need more space, though. Yeah, I guess I have some. Let's go back. All right. Now, if you're going to perform sign analysis on a rational function, we got to be concerned with two locations here. Okay, where is the numerator equal to 0? Where is the denominator equal to 0? Because that's a rational function, and we need to know where this rational function is undefined. So, in sign analysis, we have to put the numerator equal to 0, and we set the denominator equal to 0. Now, this means t squared is 1, or, by the square root formula, t is plus or minus square root of 1, which really means t is plus or minus 1. So t is positive 1, or t is negative 1. These are the values of t for which the particle stops. This is v of t equals 0 here. Okay, so a fraction is 0 when that numerator equals 0. And that's what we just found. Now, I can throw out negative 1 because, remember, t is strictly positive, times positive. Now, go to the next equation. If I have 1 plus t squared equals 0, that implies by the zero product rule, because you have 1 plus t squared times 1 plus t squared there. So that means 1 plus t squared is 0, which means t squared is negative 1, and that never happens. That never happens for real numbers, and we are working with calculus with one real variable. This is not calculus of complex variables. So t squared equal to negative 1, that simply never happens. So, okay, it looks like we only have one of these values here to be concerned with for velocity. Okay, so I actually do it this way here. I might put, let's put 0 in the middle. Let's be careful. Here's where t is 1. And at t is 1, my velocity is 0. So I only have 2 regions to check now. Okay, remember, I don't care about negative time. Time is not negative. My time is greater than or equal to 0. So I can throw that portion out. So that when I check and I have to use test points, I need, by sign analysis, numbers that are clearly in the region to test. These are my test points. And then you say, what am I testing? The velocity function, which you just have here. So, this is actually the complete sign analysis process. Let's now check by plugging in our test points. First test point t is 1/2. So wherever there's a t, replace that with a 1/2. And this is 1 minus 1/2 squared over 1 plus 1/2 squared, and then squared. So velocity at 1/2 will be 1 minus 1/4 over 1 plus 1/4. And that's going to be squared. So the velocity at 1/2 a second is going to be 3/4 over, looks like 25/16. Now, I can go all the way with the arithmetic. 3/4 divided by 25/16. V of 1/2 will be 3/4 times 16 over 25. So if I wanted to find the velocity at 1/2 of a second, I actually can do that. So this would be 4. 3 times 4 would be 12 over 25, and that's centimeters per second, I guess. The point is, even though I know the numerical value, region 1 will be positive because you're looking at sign analysis. So my test point at 1/2 will give you a positive number, 12 over 25. Okay. Let's test the time value being 2. Now, 2 is in region 2. And we have to find what velocity at 2 seconds is. And then that's going to give us, we really care about the sign. So let's plug in 2 for t. And we end up getting v of 2, which is 1 minus 2 squared over 1 plus 2 squared squared. 1 minus 4 over 1 plus 4 squared, and we end up getting a -3 in the numerator and a 25 in the denominator. So at 2 seconds, and that would be probably, again, centimeters per second, we get negative velocity. Our velocity is negative in this region, so using sign analysis. Now, this tells me everything I need to know. So you might say, what do I need to know? Well, I think positive. Let's go back. We used what color for positive? To the right, it's green. Positive is green. So where my velocity is positive. Okay. And where my velocity is negative, it's going to be this interval here. So region 1 is positive, but region 2 is negative. So let's see what this conclusion is, ladies and gentlemen. Where does your particle stop? Well, remember, v of t equals 0 happens when t equals 1 second. When does the particle move to the right? Well, that's when the velocity of the particle is positive, and that happens for t values between 0 and 1. Particle moves to the left when my velocity is negative or my time value is greater than 1. So, ladies and gentlemen, take a look at this. Stops. T is 1. Velocity equals 0. Moves to the right, the positive direction, for 0 to 1. That's the values of t. Moves to the left when the velocity is negative, and that happens for t is greater than 1. So this is, ladies and gentlemen, the important details of why we care about sign analysis. And there you go. All right. Let's try the next one. Same process. They want to know where that particle stops, when it goes to the right, when it goes to the left. So the velocity function, we're going to do sign analysis on our velocity function, but we have to get that velocity function. The position function is t cubed minus 12t plus 3. All right. So by properties of derivatives, if that's what you guys do, okay. So 3t squared, derivative of t is 1, derivative of a constant is 0. So my velocity function is 3t squared minus 12. So we need this function. And that's the function we're going to perform our sign analysis on. All right. So the first step of sign analysis is always let the function equal to 0. That happens to also be where our particle stops. So 3t squared minus 12 is 0. I can factor out a 3. I get t squared minus 4 equals 0. Divide both sides by 3, which would give me t squared minus 4 equal to 0. And then I could use the square root formula. This means t will be plus or minus square root of 4, or my t will be plus or minus 2. So I think I'm going to move everything up here. And then we're going to say that means t is 2 seconds, or t is minus 2 seconds. Those are in seconds. Don't forget, time could never be negative because my time is greater than or equal to 0. So the only time this particle stops is at 2 seconds. Okay. All right, the particle stops at 2 seconds. Notice this on my position function here. At 2, we have a horizontal tangent. So I just want to point that out. That's not a coincidence. Okay. Just want to point that out. Now, the prior example, it stops at t is 1. I can actually just look at this curve. And that's the same sort of geometry. This is where I have a horizontal tangent here. It happens when t is 1 there. We can still look at the other curve and go, oh, this is when t is 1. We have a nice horizontal tangent. We've seen that in another video. And this is another horizontal tangent where t is actually 3. So it's not a coincidence if I go back to the, I should say, the position functions and find my horizontal tangents. That's where the particle stops. T is 1 and 3. We already knew that right in here. Both are positive. So I just want to kind of verify that with you guys. It's no coincidence. It's the same idea. T is 1. Oh, we knew that. All right. And then this one, the current example, I guess we're on. T is 2. Okay. So with sign analysis, let's get out the real number line. Remember, this is our time. We're going to find the t values here. So if I told you t is 2, my velocity is 0, that's what we actually solved. So this separates our real number line into 2 regions. Don't forget, we don't care about negative time values. So don't use a test point that's negative. We can use 0 as a test point. We could use 3 as a test point. And that's for my velocity function. So I have to go back to this function. And let's test. Plug in your test points. Plug in that test point as 0. So that v of 0 becomes 3 times 0 squared minus 12. So order of operation just makes this negative 12. So I have negative velocity, ladies and gentlemen, at 0. So region 1 is, in fact, negative. All right. Let's test region 2 with the number 3 for t. So when I plug in 3 now, I get v of 3 is 3 times 3 squared minus 12. Let's double check if that's the derivative. It sure is. So we get 27 minus 12. Looks like it will be 15. And that's probably going to be, again, in centimeters per second. I'm not sure what I wrote down. I think I did that. But in this case, when the time is 3, velocity is 15, that's a positive 15. So what we can see here, ladies and gentlemen, is everything we need to know. Let's get rid of these values here, because we have the conclusion step now. Where we move to the right is when we have positive velocity. Where we move to the left is when we have negative velocity. The particle stops when our velocity is 0. So here's what we can say. The particle stops when my velocity is 0, and that happens when t equals 2 seconds. Okay, so it stops when the velocity is 0. Time is 2 seconds. All right. When do you move to the right? Well, when the velocity is strictly positive. And that happens when t is greater than 2, based on our sign analysis. All right. The particle moves to the left when your velocity is negative, and then that happens when t is between 0 and 2. And ladies and gentlemen, there you go. You know, if you want an interval notation, 2 to infinity, 0 to 2. Okay. Number 4, ladies and gentlemen. This one's going to be interesting. Okay, we're going to do the same thing. We're going to find the velocity function and perform sign analysis. So my velocity function is ds dt, d dt, where s is t cubed minus 4t squared plus 3. And you guys by now might see that you have a horizontal tangent here at 0. And it looks like a horizontal tangent at 3. So I just want to kind of throw that out there. Maybe. We'll see what that point is. Okay. So by operator notation, t cubed minus 4 d dt of t squared plus d dt of 3. Here we go. 3t squared, 2t, 0. 3t squared minus 4 times 2t is 8t. So this is my velocity. Good. All right. So we're going to try to do some algebra here. We're going to have to find where this particle stops. Stops when v of t is 0. So set this equation equal to 0 and solve for t. So now I would say this, you can factor out a t, the greatest common factor. You got t, 3t minus 8 equals 0. Greatest common factor. The zero product rule comes along, and we say t is 0. Our 3t minus 8 is 0. Add 8 to both sides. 3t is 8, and t will be 8/3. So both numbers are positive when t is 0. T is 8/3. So back here, we were right, but this value is 8/3, and this value is 0. So these are the time values where you have horizontal asymptotes, or we can say the velocity is 0 at 0 and 8/3 seconds. So great. Now, this is where the particle stops. So when I go to sign analysis, remember how this works. You might say, here's where 0, the particle stops. Here's 8/3 for that velocity function. That partitions my real number line really into two regions again, because we don't care about negative time values. This is nice and simple. That means I can use a test point for region 1 to be like +1, and then any number in region 2, I'll say 4. That looks like that might be okay as a test point. So I got to test 1 and 4 for t values. Those are test points by sign analysis. I got to test this velocity function. And, all right. Plug in now your first test point, 1 for your t. So that v of 1, velocity at 1 second, is 3 times 1 squared minus 8 times 1, which will be 3 minus 8. So the velocity at 1 second is -5, and I'll say that's centimeters per second. So the point is, you have a negative region 1. Let's test 4. So that my v of 4 now is 3 times 4 squared minus 8 times 4. 3 times 16 minus 8 and 8 is 16, 32. 3 times 16 is 8. Isn't that 48? And then 48 minus 32 looks like it'll be 16, and we'll say centimeters per second. So here's my velocity at 4 seconds. So, I mean, these answers have a lot of meaning for us. But in region 2 for sign analysis, all that means is region 2 is positive. So I think we're using green. Region 2 is positive, and then we're using orange. Region 1 is negative for that velocity function. So that's how all of these details work. So I'll leave that up for a few seconds here for yourself. We can have negative velocity. It's moving, the particle's moving in the negative direction, which will be to the left with a horizontal line. Okay, and then it stops again at 0 and at 8/3. So in your conclusion, they say, hey, where does the particle stop? It stops when my velocity is 0 And that happens when t equals 0 seconds or t equals 8/3 seconds. The particle moves to the right for positive velocity. And that happens when t is greater than 8/3. Particle moves to the left. You have negative velocity, and then that happens for t being between 0 and 8/3. So maybe color coordinating these answers helps you. You can see why you care about the sign analysis. And that's important. So interval notation, I guess, I'll put it down here. 8/3 to infinity. Okay, open circles. 0 up to 8/3. My 8/3, my writing's pretty unremarkable today. 8/3 to infinity here. Okay. All right. That's why you care about sign analysis. And that leaves us to the last example. And if the other examples have been helpful, looks like there's going to be only one horizontal tangent, and it's going to be less than 1. So let's do sign analysis. So we need the velocity function first, which will be ds dt, which will be d dt, where s is 5t cubed minus 4t squared plus 7. So 5 d dt of t cubed minus 4 d dt of t squared plus d dt of 7. So 3t squared, 2t, and 0. Okay. 5 times 3 is 15. That's 15 squared. Minus 8t plus 0. Here is our velocity function. Okay. The particle stops when my velocity function equals 0. So that means 15t squared. I'm going to go back to my blue. 15t squared minus 8t equals 0. Now, since I have t in both terms, I can factor the t out as a greatest common factor, just like the last example. And that gives us, by the 0 product rule, t is 0. 15t minus 8 is 0. Solving for t, if I add 8 to both sides, I get 15t is 8. Divide both sides now by 15. T will be 8 over 15. So 8 over 15. These are the two values of t where the particle stops. So it does look like 18 over 15, which is kind of like a half. So I'll put this in red. That's like 8 over 15. That is between 0 and 1, if you could look at the picture. But then it also has horizontal tangent here at 0. So that one was hard to see, but by the analysis, we got it. So there's 2 horizontal tangents there, so you guys can take a look. All right. Sign analysis, ladies and gentlemen. This is just like the last example. Meaning at 0 and 8 over 15, this velocity function stops. So remember, I don't care about the region that's out here because that's where time is negative, and t is always greater than or equal to 0. Time, there's no such thing as negative time. So I have two regions like the last example, and I got to be careful with my test point because I can have 1 in region 2 because 8 over 15 is about like, half almost. So I'm going to say here, let's use 2 over 15 as a test point. And here 1's a test point. Okay. So the velocity function right in here let's test this. I'm first going to put the number 1 in here because that's pretty simple to do. So if I let t be 1, 15 times 1 squared minus 8 times 1. 15 times 1 minus 8, and that's going to simply be 7 centimeters per second. So region number 2 is strictly positive, okay? Because that 7 is positive. Now, if I use a test point of 2 over 15, I think the arithmetic is going to be a lot more difficult. Let's see if we can figure this out to some degree. 2 over 15 is 15 times 2 over 15 squared minus 8 times 2 over 15. I'm going to do it this way. Well, 15 times 4 over 125 minus 16 over 15, which is going to be 4 over 15 minus 16 over 15, and that's going to be a negative 12 over 15. Yeah, I can simplify this. 3 goes in negative 4/5. Okay. All right, ladies and gentlemen. The velocity is negative in region 1. All right. Okay, we're able to get those velocities. Sometimes they're positive. Sometimes they are negative. So, all right, what does that mean now? We're looking at everything we need to know to answer these questions. Here's what we need to know. The particle will stop when my velocity function equals 0, and that happens at 0 seconds or 1 second, just so you guys know. Now, the particle moves to the right when my velocity is positive. And that's going to happen for t values that are simply greater than 8 over 15, because I'm looking right here. Region 2 is positive. Remember, it stops when velocity is 0. So maybe the colors are very helpful to see things. All right, now the particle is moving to the left. For 0, well, let me write down the criteria. When the particle has negative velocity, you're moving to the left. Now you say, when does that happen? Well, that happens for 0 less than t less than 8 over 15. That's in region 2, by the way. 0 to 8 over 15. So, ladies and gentlemen, if I move everything over, maybe that will help us with our interval notation. And 8 over 15 up to infinity. And this is 0 up to 8 over 15. All right. Looks really good. This is why we care about sign analysis, ladies and gentlemen. I hope you enjoyed the demonstration.